Hi students, let's look at this question here, which is on vectors taken from one of the RI tutorial. I believe this is question 9. This was asked by one of my students. Let's see how I can do this proficiently. So the points P and Q have position vector of A, B, and 3A minus 2B respectively relative to the origin. Given that OPQR is a parallelogram, express PQ and PR in terms of A and B. Okay, great. So I think just sketch out the diagram out. And then usually just understand that the when we put OPQR is in anti-clockwise direction, just draw label everything out, and then we just see how we can solve this. All right. From here we have O, P, Q, and R. Okay. So we told that OP is A plus B, OQ is 3A minus 2B. So we've got this OP is A plus B. Then OQ is 3A minus 2B. I think finding PR shouldn't be an issue. So because PQ shouldn't be an issue, PQ is just basically, remember, the way to think about it is just final minus initial. So it's OQ minus OP. This is the fastest way, okay? If not, we could just break it apart like what we did in secondary school, which is PO plus OQ equals to minus OP plus OQ. But usually what I tell my students to do is just take final minus initial. So you just take Q minus P. Okay, that's about it. That's the fastest way to do it. Anyway, you need that, right? So this will be 3A minus 2B minus A plus B. So first that is done. This is PQ. Now then the next is we need to find PR. PR is this guy here. PR. Maybe I just use this column. PR is this guy. Okay. PR is obviously PO plus OR. Okay, but we already found PQ. Just understand that if this is a parallelogram, meaning to say the opposite side direction, they are like equal vectors. This is 2A minus 3B, right? This opposite will also be 2A minus 3B, not an issue. So what we need is know that PQ is equals to OQ. Okay, then if we need to find PR, it will be OR minus OP, meaning you always take final minus initial. Then we can write the OR is PQ. So OR is just PQ. This will be 2A minus 3B. Okay. So remember OR is PQ. So I'm just gonna use 2A minus 3B, that what we found just now, and minus of OP, which was given. So I found out that my PR is A minus 4B. Great. So done that. Now by evaluating two scalar products, show that if OPQR is a square, then this will hold true. Okay, so meaning the modulus A square is equals to 2 modulus B square. Let's see how we can do that. So this is our square, OPQR, right? So now take note, by evaluating two scalar product, the key thing here is two scalar product. Then show that OP, if this is a square, then this will hold through. Now, I will just go through straight up. I think the first thing that students usually make is knowing that the scalar product we need now. If it's 90 degrees, the scalar product is dot is 0. Right? So meaning this case here, if I were to write this as OP, dot with PQ will be 0. This is a one scalar product. And the other one that usually students will oftentimes forget when it comes to square is that the diagonal is also 90 degrees. So this guy is also 90. Okay, so just don't forget that PR, because we already found PR here, right, from the first part. So PR, the diagonal PR dot with OQ is also equal to 0. So OP dot OQ 0, PR dot OQ 0. Let's see what it will yield from here. I just know that we need two scalar products. These are the first two that I could think of. So this is what I get. OP perpendicular to PQ. So the dot product will be 0. Then OQ, the diagonals are also perpendicular to each other. So the dot product will be 0. So then I'll just put in what we found just now. So OP was given, right? PQ was also found here. Okay. So everything that we have, I'm just going to put it in terms of the vector algebra. Then I'm going to expand the left and the right. So expanding this and expanding these two, expand it out. So there will be the A dot 2A minus of plus A dot minus 3B plus B dot 2A plus B dot minus 3B. Okay, this is equals to 0 from the left hand side. So remember, A dot A is obviously mod A square dot product. B dot B is also mod B square. Then after which this guy, the 2 can just be brought out, right? So then this is minus 3A dot B. They are then this would be the commutative, right? This could be added up together. So this is 3 mod b square. So this is from the first expansion we have, right? From here, what we get is, I think this would be a dot b on the other end. So 2 mod a, 3 mod b square equals to a dot b. So this is the first one. Okay. So if I were to expand the one on the left here, okay, I will get this guy. Then I'm going to move on to expand the second dot product. So for the second dot product, same thing. So 3a dot a minus 3a plus 3a dot negative 4b minus 2b dot a minus 2b dot negative 4b equals to 0. Okay. Then you're going to expand everything as usual. So this is how we expand it. Okay, so shouldn't be an issue. I think we just need to merge both of them together. So for this guy, you can say it's 14. The one here is 14ab. So I usually what I'll do is I'm gonna just multiply 14 to the first equation here. Multiply 14. Okay, throughout. This will be 28 mod a square. Then 3 multiplied by 14, what will we get? 3 multiplied by 14 is 42. Minus 42 mod b square equals to 14a dot b. Okay, then you just combine both of them, because you just need to take 1 and 2. By combining 1 and 2, 14ab, this will be equals to the other one. Then we could just try and see what we get. There you go. Once you combine them, then we're gonna just put them together. This is 4 mod a square. 4 mod a square. There will be 25. Is it 20? Sorry, I wrote wrongly. This is 42. 42 over here. 42. Get a 50. Yeah, 50 mod b square. Then we just divide by 25. You get a grand total of mod a square equals to 2 mod b square. Is that what you want to show? Alright, that's what you want to show, right? Right. So that's how you do this question here proficiently. If you have any questions, please do let us know, and I'll see you in the next question.